Back to the 2017 AP exam. We are going to be taking a look at question number 5. So let's go and get started. Question number 5A says, find the slope of a line, tangent. Oh, look, tangent line. I love the phrase when they say tangent lines. Anyway, so they just want us to find the slope, which is, of course, of a derivative. And here they gave us this really ugly looking function right there. So let's go ahead and take that derivative, f prime. Now, you can use quotient rule if you want to, or you can just use chain rule, right? You can think of this as 3 times 2x squared minus 7x plus 5 to negative 1. Use chain rule, and that's going to give us, what's that going to become? Negative 3. And when I take this derivative, that becomes to a negative 2, which you can put that entire quantity on bottom, minus 7x plus 5 squared. Don't forget your chain rule times the derivative of the inside. So times the derivative of the inside, which would be 4x minus 7. And there's your derivative right there. It's pretty easy to do, not too bad. But they want us to find the derivative at 3. So when we plug in the 3 here, we get negative 3 times 4 is 12 minus 7 all over. What's that become? 2 times 3 squared is 9 minus 3 times 7 is 21 plus 5 squared. And seriously, leave it like that. The AP is okay with that. Leave it alone. Don't touch it. Don't be a hero. Okay? But if you are brave and you're like, Mr. Warner, they want me to solve it. If you're brave, that's just going to equal negative 15 over 4. But seriously, don't simplify that at all. Leave it alone. Like a freshman walking down the hallway talking on his phone. Just leave it alone. All right, question B. All right, let's see here. Question B says, find the x coordinate for each critical point. Oh no, critical point. That sounds like me for a derivative between 1 and 0.25. So that's basically just setting the derivative equal to 0 or d and e. So let's see here. So let's set our derivative equal to 0. Remember, when you set the derivative, which is up here, when you set the derivative equal to 0, that's just setting the top equal to 0. And that's going to give us 4x minus 7. And if I set that equal to 0, we get x equals 7 over 4. All righty. So when we set it to the bottom equal to 0, d and e, let's see here, 2x squared minus 7x plus 5 equals to 0. And what you're going to wind up with is it's going to be outside our range. So nothing in range. Okay, it's going to be out of our range. So we don't worry about that one. All right, now we want to find out if this is a maximum or a minimum value. So you're going to get 1 point for the x coordinate, and then you're going to do your sign chart because they want to know if this is a relative max or relative minimum or neither. So it's a sign chart between 1 and 2.5. And let's see, the 1 point that we have here is, what's that, 7 over 4. And we look at the derivative only. Now, when we look at the derivative, f prime of x over f of x, we're lucky because the bottom of the derivative is always going to be positive. So I only have to worry about this range right here. The bottom is always going to be positive because up here in the derivative, we're always squaring the bottom. So we only have to worry about the top. So if I pick a number between 1 and, what is that, 1 and 7/4, between 1 and 7 over 4, what is 1 and 7 over 4? That is 1 and 3/4. So I can pick 1.5. And if I plug 1.5 into the top, it's negative 3 times that 4x minus 7. And if we type that in, if we plug in like x equals 1.5 over here, what we're going to wind up with is a positive value. So it's going up right here. And if I pick something between 1.75 and 2, like if I pick x equals 2 right here, plug that into our derivative, we get a negative and it's going down. So we know at x equals 7 over 4, which f of x has a relative maximum. And that is because, let's write out the reason, because f prime of x goes from positive to negative. And there's your answer. You only get 1 point for that. This used to be worth a lot more points. You used to get like 2 or 3 points for this one. But now that whole question only worth 2 points because they added this part D to this question right here for us. And honestly, this year, I can see a question like number 5 on the AP test for the 2020. So let's go and take a look at question C here. Excuse me. Using the identity that this fraction is equal to the sum of these two fractions. It looks like to me that they decomposed the fraction right here. So that sounds kind of familiar to me, right? Evaluate the following integral. Evaluate the integral from 5 to infinity, or show that the integral diverges. Oh, diverges, that sounds kind of familiar for us. But the first thing I notice is right here is that this is an improper integral. So we can't leave it like this. So we have to rewrite the improper integral. So we would write this as the limit as b goes to infinity from 5 to b. Now remember, this is f of x, but to have me rewrite it this way, 2 over 2x minus 5 minus 1 over x minus 1 dx. Really what they're doing here, we're integrating this function right here, we're integrating this, but we're using partial fractions is what we're doing. This is actually a partial fraction when we integrate it. So they just did the partial part for us. So let's see here. You're going to get 1 point for writing the expression. Okay. So next we're going to integrate this one. We're going to get the limit as b goes to infinity. And when you integrate this one's not too bad. This becomes 2 times the natural log of 2x minus 5, but I'm integrating, I'm going to divide that by 2. That's my u sub, right? U is 2x minus 5. If I divide by the 2, minus the natural log of x minus 1. And this is going to be evaluated from 5 to b right there. So you don't have to worry about the 2's right here. They just cancel out. Option for us, because it's natural log, I am going to use a natural log property right here. I'm going to write this as a single fraction. This becomes the natural log of 2x minus 5 over x minus 1 from 5 to b. And if we evaluate that integral, we're going to get the limit as b goes to infinity of the natural log of, let's go ahead and do our FTC. This becomes 2b minus 5 over b minus 1. Minus, plug in the 5, the natural log of, that becomes, what's that, 2 times 5, that becomes 5 over 4. Right here. And now we're going to plug into our infinity. Oh no, if you notice, there it is. Oh, look, this right here, I get infinity over infinity right here. So I have two options. Option one is I can use multiples, or I can just use what I know. If I know that this is just a horizontal asymptote, that's really simple. We're going to get the limit as b goes to infinity of the natural log of 2b minus 5 over b minus 1. That just becomes the natural log of 2. That's just one of our properties from the beginning of the year with limits. So I can write this whole answer now as the natural log of 2 minus the natural log of 5 over 4. And again, don't box in your answers traditionally on the AP, but I just want to use that just to clarify the difference in the answer. Remember, over here, we're just saying, hey, look, if I'm taking the natural log, the limit at b goes to infinity 2b minus 5 over b minus 1, that's just 2. And because of the natural log there, we get natural log of 2. And that's where that comes from. And this would be, let's see here, you get 1 point for writing it out, 1 point for your antiderivative, and then 1 point for your answer. That's worth 3 points right here. Now, so notice, does this converge or diverge? Yeah, this converges right here. Which brings us to question D. Let's take a look at question D right now. For question D, it says determine whether the series converges or diverges. State the conditions of the test used for determining. Well, from part C, we know that the integral from 5 to infinity of f of x converges. We know the integral converges. And remember, this is f of x. We know that that whole integral converges. So we can go real quickly. Therefore, because f of x is continuous, positive, and decreasing, those values are decreasing over time on the domain 5 to infinity, we can say the series also converges by, and this is our integral test. Ta-da! And that's it. That's our integral test right there. Because part C said the integral converges, so therefore the series also has to converge if the function is continuous, positive, and decreasing. Now, sometimes people are like, Mr. Warner, I forgot the integral test. What else could I use? Well, we could use a comparison test. So let's take a look at another way that we can solve this one right here. Let's say we let b sub n equal 1 over n squared. Remember, a sub n is 3 over 2n squared minus 7n plus 5. So if I let b sub n be 1 over n squared, we can see where that comes from. And then I can use a comparison test. Well, step 1 of my comparison says, well, what if we let we go from 5 to infinity, 1 over n squared? Well, we know that p is 2, which is greater than 1. Therefore, this converges by p series. And then step 2, I'm going to use limit comparison. I take the limit as n goes to infinity. I'm going to use limit comparison because a sub n is pretty nasty. And if I do limit comparison, I'm just going to flip it. I'm going to get 3 over, what's that, 2n squared minus 7n plus 5. Flip b sub n, I get n squared over 1. And I'm going to get 3/2, which is finite and positive. Therefore, the series converges by limit comparison. Just another way to do it, and either way you do it, it's just worth 2 points. You will see a comparison test. I would say question number 5 you should know for the AP exam. You will probably see one like this one on the test because especially on the 2020 when they're trying to condense a lot, there's a lot to this question right here. So take a look at question number 5 again. Ask questions if you need to. Watch the series again, okay? And I'll see you guys on question number 6.